Hi there, and welcome to this first tutorial of an ongoing series regarding touching typography. Whereas the Kinetic Typography tutorial series are more focused on the development of a tool for iterating different text animations quickly, this new series will grab examples from the field and rebuild them in Touchdesigner. Where a lot of these animations are pre-baked, with Touchdesigner we'll be adding a real-time element to it, or how we would like to call it, touching it. Have fun! I first would like to give credits to Pocketa 12. I used to do these animations in chops, and as long as you keep your work very organized, it will work perfectly fine, but things can get very messy very soon, and working with tops is sometimes a bit more convenient, so credits for him to show me around the whole top world. I'll put a link in the description for his Patreon. Go have a look. Very fascinating stuff. If you're looking at one pixel, you're basically looking at 4 channels of information. So I'll close it up with a null. And if I convert this one to chops, you're looking at 4 channels. And if we change the color, for instance, a little bit lower, you see that the values are changing. If it's all black, it's 0. And if it's all white, it's 1. If you go further, you see that the values aren't changing. If you convert this one to, let's say, 32-bit pixel format, we're now going to increase, you see that these values are changing with it. So this 1 pixel basically holds 4 numbers. You can adjust alpha, you can adjust only the red channel. And the fun thing about it is that if you would just use regular compositing tricks like add and subtract, just going to copy this one and we'll give this a value of 5. This one is multiply, switch it to add, see, this is 1, this is 5, so you end up with 6. And there are all the operations you probably already know, like subtract, add, multiply. And this gives you a lot of tools to work with pixels. And another thing I would like to mention is that if we pick, for instance, a noise, make this a little bit smaller, 50 by 50, so we have 2500 samples. Going to pick a noise chop and replicate that. So let's set this one to 32-bit so we can get past 1. Set this one to monochrome off, so we have red, green and blue. We can control this separately from each other, otherwise it will all be the same numbers. We'll give this one 4 channels, an R and G, a B and an A. Samples 1 from 2500. If we're going to animate this, for instance, the X value, put it in a simple expression, abs time.frame. We're going to do this here as well, abs time.frame. And if you take a closer look at the cooking values, you see this one is moving between 0.1 0.18 and 0.24, I guess. If you take a close look at this one, you see this one is already around 5. So they're both showing the same values in a different way, but you see there is a very efficient way working with tops and keep your CPU cook time lower. So as long as you're staying within the tops and don't do any conversions to chop values, you can keep your project very optimized. And that's the convenient thing about working with tops. What I usually do with analyzing these kind of animation, I grab a piece of paper and I'm just going to write down what am I actually looking at. So the first thing that comes up is I'm looking at a 4x4 grid. So square, 4 columns, 4 rows, and every little rectangle is showing a character. And it seems like that every character is scaling in a randomized way, but that's not actually the case, because when we're having a closer look at this first row, you see that the entire row, the scaling in height for every character is the same. So this entire row is scaling in height, and the same is applicable for the second, the third and the fourth, like this. If you take a closer look at the width of the character, you see that in the first row every character is scaling independently from each other. But if we are looking at the columns, you see that this entire column is fixed to each other. So just like with the rows, this one is scaling, this one, and this one. So what we need is a randomized height for the entire row and then a randomized width for the column, and that 4 times. So we'll probably end up with a top that's 4 pixels wide, and we can use the red channel for the width and the green channel for the height. The second thing that pops up is that this entire animation is fixed within a certain boundary. So no matter how much these independent characters are scaling, they all are going to be fixed within this rectangle. So if we put a coordinate system in here, we can say that this one is 0.0, this one 1.0, this is 1.1, and this is 0.1. So no matter how much the columns and the rows are scaling independently from each other, it's all going to be fixed within this entire rectangle. So the sum of all these scales, let's start with the width, the sum of all width, so sum width is equal to 1, and the sum of all height is also equal to 1. So this is the data we're starting with, and we'll hop over to Touchdesigner and see how we can translate this. So we're in Touchdesigner now. I'm gonna play the timeline. I think I'll start off with a container. Call this one noise. Give it a global up shortcut to access it later from anywhere in the network. Going inside, start off with a noise, and just like we showed in the drawing, we give it 4 by 1 pixel. Set this one to 32 bits so we can get past the 1 maximum value, so we can go past white. Set it to nearest pixel, switch monochrome off so we can control red, green, blue separately from each other. Close it with a null. I believe the shortcut was Alt-N. Yeah. Call this one out. And let's animate it. An expression, ABS time, absolute time, frame. Maybe a bit fast. So if we use seconds, a bit slower. Okay. Next in line, we're going to build the actual grid. Call this one grid builder. Up shortcut as well. And we'll just use a select. Up, noise, up, out. Control M, yep. So there's our noise. The thing that I forgot to mention with the drawing is that the scale isn't going beyond 0. So what I'd like to do is I put a limit in here. So values are going to be 0 or more, not less. So I put this one to clamp, minimum value 0. Set this one to nearest pixel. Close it with a null, Alt-N. There it is. The other thing I mentioned with the drawing is that this noise gets fixed between 0 and 1 scaling. So how do you make sure that the sum of these pixels always going to be 1? You just divide it by the sum of itself. So I'll show you how that works. Take a select, put a null in here, and I'm going to use an analyze. And I'll just use sum. So this analyze is 1 pixel. It's giving you the sum of all these 4 pixel values together. We use a transform and a resolution, custom resolution 4:1, nearest pixel resolution. So this represents the sum of all red, green, blue alpha values of this noise. And if we use a composite and we divide this one with the sum of itself, you now have a noise where the sum of all its parts is 1. Let's change this one to nearest pixel. Take a closer look. Convert this to tops. And to a dead. With the red, the green and the blue values. And if we sum this up, you can always see this by the alpha, because that one is moving. It's 1. And if we pause it for a second, you have to bring out a calculator, but if you just eyeball it for a while, you see that every sum of every channel is 1. So whatever happens with the scaling of this noise, it's always going to be 1. Just like in the drawing I've shown you a minute ago. Since our animation is a 4x4 grid, I'm going to transform this one as well. Custom resolution 4x4. Set this one to nearest pixel. So you see that for the width we use columns, and you see that we're only going to pick the red channel. But in this transform top, you see the red, the green and the blue mingled in with each other. But that's not a problem, because we're going to isolate it further up anyway. But the red value of this column represents the width of the first one, etc., etc. For the rows, we're going to do a neat trick, and we'll use a flip. Put it in here. Set this one to nearest pixel. We're going to flip this one around and composite it on top of this one. We'll use bottom left. And if we use a composite, wait, I'm going to use a reorder, because we're going to isolate the channels, and this reorder top, it will let you pick a channel from an input. So the height, like we mentioned in the drawing, is going to be the green channel. So that's the second input. Disconnect. Second input picking the green channel, and the first input, the red channel. Set this one to nearest pixels again. So now you see that we also have a row, randomized row values on top of the randomized column channels, and the columns are the red channel and the rows are the green channel. So in one top we have all the information we need regarding the scaling of the characters. Close this one with a null. Maybe this is a little bit abstract at first sight. So let's see how this is actually looking if we instance the characters. Call this one characters. And we'll just start with a text. And we'll just pick the capital A. And we use a nice fat font, Arial black. The reason why I'm working with sops is that if you render this out, and when this is scaling up and down, the edges are always going to be razor sharp. In an earlier animation I used tops, but then you get all this anti-aliasing effects and it doesn't give that crispy, nice, razor sharp look. So we're going to use the sops for this. I'll close it up with a null, Alt N, into a geometry. Component. And let's select, no, wrong select. Let's see. This is going to represent the scale values of our sops. So when we're going to do some translations up here, so I'm going to borrow it, put it up front, the null to null again, call this one out, first out. So up, grid builder, out, Control M. So there's our select. Put a null in here. Call this one scale. So if we're going to the instancing tab, switch this one on. For the scale operation, we use the scale top. And the X is going to be the red value. And the Y, the green. You see that there's already happening something. But it's quite a mess. First thing I would like to do, split this one. Going to my noise. Going to animate this one a little bit slower. This makes me a little bit sick in my stomach. Multiply it by 0.1. That looks a little bit better. Okay. Where we have looked at the scale within this animation, we also have to look at the positions of every character within this fixed square. So if you take a closer look at the first character, its position, let's make a graph here. So this is the position, let's see, X position. And this is just the index. So this is the first character, the second, the third, and the fourth, the first row. So this is the first row. The position of the first one, the T, is 0. Like this. The second one is the scale of the first character. Like this. So the O is positioned at the scale of the T. And if you take a close look at the M position is the scale of the first and the scale of the second character. And the position of the E, you can already guess, is the scale of the first plus the scale of the second plus the scale of the third. So now we have this entire data set and we are trying to recreate this inside the top, a 4x4 top. So for every character in the width, we have its position data, and the sum of every column will represent the position of the characters. But we'll hop over to Touchdesigner and I'll show you how this works. So in our grid builder section again, we have to put in the position values of all these different text sops. And like we've shown in the drawing, we need to find this shape and try to recreate this one in tops. So the first thing I'm going to do is I'm going to need some kind of matte mask on top of this one, where I'm only going to pick out the values I need in order to calculate the positions. So I'm going to put a matte in here. And I'm going to build some kind of mask. Do it in a container, otherwise it gets messy. Inside I start off with a rectangle. And I just want to have this cut in half. So I'll start off with heading into the direction how the mask is actually going to look like. First of all, I'm going to put this one at 0.0. Gonna close it up one for now. Center 0.5, 0.5. So there it is. Press H to home it. In order to slice it up here, I only need to delete this point. And if we right mouse click when viewer active, you have the display options. You can show the point numbers 0, 1, 2, 3. So I'm going to need to delete the third point. First isolate it with a group. Set this one to points. Number 3. And if we use delete sop, we can select our group, delete points. So now it's deleted. We have our triangle shape. Close it with a null. Alt N shortcut. Geometry. So we need to render it out in order to make a mask top out of it. So we need a camera. And the render top. Gonna make it white because we use a white in the mask. Let's see, constant material. It's already white, so that's just fine. And the render needs to be 4x4. Going to make it hard coded first, and we'll optimize it later. Nearest pixel. Going to need an orthographic camera, so there's no perspective involved. Let's see, orthographic. Yeah. Set the width to 1 and the position, just like with the rectangle, 0.5, 0.5. So now we have our triangle-ish shape, but you see that we have this aliasing effect, so we need to switch it off. So it's starting to form towards our mask we need. And the way why I set this up is that if we are going to change the resolution of this one, let's say 10 by 10, it's always going to be the shape. So we don't have to mask out the thing by hand. And if we're going to make this one animation real time in the future, it comes in quite handy to set it up like this. But like we've shown in the drawing, this one doesn't need to be a pixel, because the position of the first scaling character was 0. So what we do, we'll just move it aside 1 pixel with a transform. Nearest pixel, nearest pixel, transform pixels 1. We use an out. And we put the mask in the third input. This one is the source, the first one. And everything that is not white needs to be alpha 0 or black, doesn't really matter. We just use a constant 4x4 alpha 0 nearest pixel, nearest pixel. So this is starting to form our positioning data set. I'm going to close it up with a null. So it's starting to take shape. And like we've mentioned in the drawing, the position value of every X, so the first one is 0, so there's no pixel in here. The second one needs to be the scale of the first character. The second one needs to be the scale of the first and the second. So we're going to need to sum up every column, and we do that with an analyze top, analyze, set this one to columns, nearest pixel, nearest pixel. So you see the first one 0, and this one is going to be the sum of every pixel stacked up. So we are working towards our positioning data set. I'm going to use a transform because we need a 4x4 grid. So custom resolution 4x4, output resolution nearest pixel, nearest pixel. And we have to do exactly, well, not quite exactly the same thing for the height. So that would be the green value. So we need to sum up the rows. Just copy this analyzer, set this one. I have to set that one to sum, I forgot. This one as well, set this one to rows. And just like we did here, we need to composite again in one data set, so we have the width and the height position in one top. So transform, make it a 4x4 grid again. Nearest pixel, resolution. So we're going to use the red channel from this top and the green from this top So we pick our reorder again. Reorder. First input, red. Second one, green. Nearest pixel, nearest pixel. So these are our positioning values for every character in this grid. Close it with a null. Line it up nicely. Call this one out 2. And if we go to our character instancing section, going to copy this one, call this one position. We use the out 2 like that. We use the translate section, and that's the convenient thing about the more recent builds of Touchdesigner. You can pick different tops and chops for every operation separately, whereas in the earlier builds you can only pick one chop or top, so you had to compress everything in one, usually chop, the way I worked. But now they've split it, so we can use different ones. So the position, X value, position, R, and the G. Okay, you still see that it's not quite working yet. It's starting to take shape. And there are a couple of reasons for this. When we were building this masked out shape, we would like to have the position value of every scaled character separately and stacked it on top of each other. But if you take a closer look at this one, and we use this one, so the columns, to form the shape for the red value, so the width. So if we put this mask on top of this, you see that every pixel stacked on top of each other is just the same. So this one is 0, that's correct. This one is greenish, that's correct. But the third one, you see, is green, and that one is green as well. So in order to fix this, we need to flip this one around so that the value of every column becomes a row and then sums up the way we need it to be. And that's quite easy to fix. We'll just put a transform in here. We're going to show our geometry component to look for an instant reaction. Nearest pixel, nearest pixel. So if we rotate this one 90 degrees, you see something is happening. We're almost there. You see that the width of the columns is already working, and it's fixed between 0 and 1 nicely. You can render this one out with the camera, render. Set the camera to an orthographic with 1, position 0.5, 0.5. Make this one something like 1280 by 1280. Give this one a white material, constant. You see that the Y scaling and the Y positioning aren't lining up nicely. And the reason for that is that it's calculated the other way around. So this 0 position Y value has to be here, and this pixel needs to be there. And we can fix that very easily with a flip. So I'm going to flip this one around. Nearest pixel. Flip it along the Y. And you see that also the Y scaling and the positioning is lining up nicely. And the first thing that I'm already noticing is that the last character is off screen, and the top of this character is not lining up very nicely with the top or the boundaries of this render top. And the reason for that is that this text sop is not exactly 1 by 1. You see that it's a little bit bigger in the X direction and a little bit smaller in the Y direction. So we can fix this by hand. But the annoying thing is that we have to do this for every character. So we're going to use a couple of expressions to transform every character, to read the values of this character input and translate it in a particular way that it fits exactly between 1 by 1. So the first thing we do, we're going to analyze this text sop with a sop, chop to sop, let's see, sop 2. Picks the text 1, and you see that this sop represents every point of this sop. So what we need is to analyze. I'm going to close this one for now, we don't need it. So analyze this text sop by looking at the maximum X value and the maximum Y value and stretch that one up to 1. Or in this case, we're first going to look at the position. So we'll use an analyze. We're going to look at the minimum value. So you see it's not exactly at 0, the y is, but the x isn't. And we're also going to look at the maximum value. So you see that this one exceeds x, and this is one exceeds 1, this is underneath 1. So the first thing we are going to do, we're going to compensate this difference in the transform section. So a math multiplied by -1, so we get minus values. And in the transform section, close to the one and null, just going to compensate this with op null to dx. Like that. We'll just put in a y as well, because for this capital A it's situated at 0, but that doesn't give us the guarantee that it's with every character, so we'll fill in the exact same expression at the y section. Y. Like that. So now this position here is exactly 0.0. And now the scaling. So this one needs to be fit within a 1x1 rectangle. So we're going to use a math again. And a constant. This one will be 1. So the first thing what we need to do is that we're going to subtract the maximum value or the minimum value from the maximum value, because we've transformed this one. So the maximum value here actually isn't right, so we have to compensate this with a math. Put this one above, so this one gets subtracted with this value. Combine chops, subtract, so we see this value minus that is that. So another math again to stretch this up to 1. And we do that by dividing it. So in order to get 1, you need to divide 1 by this, and you get the value you need to scale this one up. So combine, divide. So in order to get dx is 1, we need to multiply it with this. And in order to get ty 1, we need to multiply it with this. So null again. Let's go to the transform. The scale section. Just copy it. This is the null 3, and it's the first channel, so 0. See that it's already lining up. For the Y, first, second, see, if we zoom out, take a closer look at our render section. It seems like that it's lining up nicely. We'll just try a different character, like the B. Let's have a look. You see that the belly of the B is off screen. And the reason for that is that we have to adjust the pivot of this one as well, because the scaling needs to be calculated from a different position. So in order to compensate that, we just use -me.bar.tx. For this one, -me.bar.ty. And now you see that the scaling gets compensated, and now it's lining up nicely. And the fun thing is that we now can change our noise stop. So we go to our noise section. Let's see if you can pick something different. Here's one. You see that it's reacting real time. Just play with it. Maybe let it move a little bit faster. So now it's starting to look like the animation we've shown at the beginning. You can play with it, try a different seed. And it's all staying fixed within a 1x1 grid. And this is basically the hard stuff, but we like to have a real-time input where we can type in a sentence and this grid will adjust in real time. And there are a couple of steps we need to take, and I will show you that in part 2. I'll see you there.